X-ray crystallography is a powerful technique for visualizing the structure of protein. It is a tool used for identifying the atomic and molecular structure of a crystal. Here, beam of incident X-rays to diffract into many specific directions. We can obtain 3D dimension picture of density of electrons within the crystal. Stellocrystallography can locate every atom in zeolite and aluminosilicate. The English physicist Sir William Henry Bragg pioneered the determination of crystal structure of X-ray diffraction methods. X-ray crystallography is a complex field that has been associated with several of science's major breakthroughs in 20th century. Using X-ray crystal data, Dr. James Watson and Francis Crick were able to determine the helix structure of DNA in 1953. And also in HIV infection process, Dr. Peter Kim, a scientist, was able to determine the structure of key protein, which is responsible for HIV infection. X-ray diffraction. It is a type of light diffraction which allows X-ray crystallography to specify molecules or atom. Here, X-ray beam is used to hit the crystallized molecules, and then that molecules will diffract the X-rays which hit them and forms a pattern, and this type of pattern is known as X-ray diffraction pattern. X-ray diffraction X-ray crystallography involves two types of laws. One is Bragg's law and another one is Thomson's scattering. In Bragg's law, it can be determined by using n lambda is equal to 2d sine theta. Here, X-ray diffraction results from an electromagnetic wave impinging on a regular array of scatters. Thomson scattering is a X-ray scattering which is determined by the density of electrons within the crystal. Since the energy of an X-ray is greater than that of valence electron, the scattering may be modeled as Thomson scattering, the interaction of an electromagnetic ray with a free electron. Instruments and components used in X-ray crystallography are detector, X-ray source, crystal on the end of mounting needle, and liquid nitrogen steam to keep crystal cold, movable mount to rotate crystal. Types of X-ray devices used are electrons are responsible for the diffraction and intensity in crystallography, and also electrons they scatter X-rays which is weaker than heavy elements, and knowing this protein crystallographers use high intensity X-ray sources such as rotating anode tube and strong synchrotron X-ray source for analyzing the protein crystals. For using X-ray crystallography process, there are procedures which we need to follow. First step is by crystallizing a protein of interest, four critical steps are taken to achieve protein crystallization, purification of protein, and protein must be precipitated by dissolving it in an appropriate solvent, and also that precipitated solution is supersaturated by adding salt to the concentrated solution of protein. And while these crystals are growing, since nuclear crystals are formed, this will lead to obtaining actual crystal growth. In second step, X-rays are generated and directed toward the crystallized protein, and then where these directed crystallized proteins are scattered in various directions, and these scattered X-rays are observed by calculating their sides and angles, and their pattern of scattering reveals much information about the structure of protein. In third step, an electron density map is created based on the measured intensities of diffraction pattern on the film. The Fourier transform can be applied to the intensities on the film to reconstruct the electron density distribution of cycle. And when interpreting the electron density map, resolution needs to be taken into an account. The resolution of 5 angstrom to 10 angstrom can reveal the structure of polypeptide chains, and 3 angstrom to 4 angstrom of groups of atom, and 1 angstrom to 1.5 angstrom of individual atoms. So when the X-rays are diffracted through various proteins or DNAs and the film falling on photographic plate. Applications of X-ray X-ray crystallography are detection of HIVs and arthritis, and also in dairy sciences like uh, dairy products or the milk is analyzed through X-ray crystallography to find its orderly arrangement or that protein molecules which are present in milk and analysis of milk stones. Whereas